Hey there everyone, Eric here from Hive49RC. If you're a longtime viewer of the channel and want to help support me in making the videos that I do, consider becoming a member of the channel. That'd be greatly appreciated. Welcome back to the MOA build. Between episodes, I've done a little bit of fiddling with the suspension on this thing. Just to get you guys up to speed, I took and flipped the front upper links around because the bend in them was contacting the motor and causing some suspension binding. And I also flipped the rear lower links around because when I articulated the rear axle all the way to one side, I was able to push the lower link underneath the upper and it would get stuck and not fully decompress. But that's not an issue anymore, I got that taken care of. I also put some 13-tooth pinions in, front and rear. I greased up the transmissions, I got some of the bearings shimmed because they were really sloppy and loose in there. And there was a lot of like sideways play on the gears and such, so I got that all taken care of. I spent some more time messing around with the programming on my radio, and I was actually able to get the variable drag brake to work, which is super awesome. It's going to be really hard for me to show you guys on camera because just by me turning the rear axle, you know, like you're not going to be able to tell what the drag brake rate is. But today's episode, right, what are we doing? I mean, you guys already know, we're making a set of custom CNC wheels, but they're not going to be billet wheels. They're going to be layered. It's going to make more sense when I show you guys on the computer, but they're going to be 2.9 size wheels to fit these 2.9 1/6 scale Hyraxx tires. Now, I'm not going to be running these, although I will give these a test before I cut them up. I'm going to be making cut and shut tires out of these, not today, in next episode, by cutting the sidewalls out of these tires and basically attaching the tread from the Ibexs to it. And just as a size comparison, there you go. I think that's all I've got to cover. Let's head over to the computer and take a look at our design. Alright, here we are inside of Fusion 360 as always. This is the design that I came up with for my wheel, and as you can see, it's not a single block, it's layers. So these are the two outer beadlock rings, and then this is the center plate that is going to get mounted to the hub itself. Now the one thing that's not modeled in here is there's going to be a piece of pipe that goes around the outside of this wheel that then these beadlock rings are going to clamp the tire bead down onto. So it's going to act just like a normal beadlock, but I just didn't model the piece of pipe that's actually going to sit around the outside of the wheel. And then this is just how I've got them laid out for machining. I've got the center plates here all in a row just because that's how it's going to fit my material better. And then the rings, I'm going to have to make 2 sets of these because obviously you need a ring for each side, so that's 2 per wheel, 8 total. This was one of my like early designs, and it only really looks good with sharp corners, so like obviously I can't make a sharp corner like that on the milling machine, it has to be rounded, and this design with rounded corners just looks terrible, so I went with a sort of a spiral sort of shape, and I've got 2 going in one direction and 2 going in the opposite direction so that they'll all, you know, match up like they're supposed to. That pretty much covers it. With that, I'm going to head out in the garage, get a piece of wood clamped down, and start test running my CNC programs. Okie dokie, I found myself a piece of plywood that will fit both sets of programs on it. I situated a piece of wood underneath it as well, just in case I go too deep for some reason. I shouldn't, hopefully, but, you know, doesn't hurt to be safe. Got my first tool in the machine. Let's go ahead and get this thing running. All was going well until I went to my chamfer program, and this is not right. The chamfers in the CAD program, the chamfers in my design are a good size, but this is way bigger than the ones that I designed, and I know exactly why that is. I definitely messed up my... Guys, I'm so fucking burnt out. I don't want to be fucking doing this. I just want to break, man. Just want to go relax. This ain't fun right now. I'm fucking burnt out. It's like, I don't even want to do YouTube anymore. Like, when do I give up on my dream? What's the point, you know? Hey guys, Erica here. I have really no idea what I filmed before this, but I think I'm going to be reusing the beginning segments of this video that I've been working on, or that I've filmed earlier. But I've kind of picked it back up again, and let me show you what I've done. As I recall, I was going on about the outer chamfer on these beadlock faces, and the issue was that they were way too deep and coming way too close to the holes. Now, this is obviously not the same batch that I showed previously. I did these this morning. I face milled a portion of the piece of plywood so that hopefully it will, you know, account for any bowing this way of the wood as it's clamped down. I mean, I recognize this is not the best way to be doing it because I am trying to get accuracy out of something that is inherently inaccurate, aka the piece of plywood. But this is good enough for me for now, and next time I'll be doing something different. The chamfers here were still too small even after face milling it. This corner portion here is the most accurate because this is where I zeroed my tool off. I want my 1/4-inch rod to match up nicely with the edge of the chamfer, and it was too big over here. It looks pretty close, but it's not. Sorry for my shaky hands. It looks close, but it's really not that great. But if we come over to this one, it matches up with the aluminum rod a lot better. And so I shrunk them down a little bit, including the chamfers here on the little curved slots. Reason for shrinking those down a bit is because I wanted to bring them a little bit farther away from this center recess. This section for these ones was also face milled, just not quite as much as that one because it tore out really bad over here because it like went past the top layer. So I tried to just take off a very little bit, but it got more or less flat all the way across for these. Now what I can do and what I'm going to do for the actual aluminum ones is I'm going to run this chamfer program first so that if this is perfect, great, I can stop there. But if I want them to be a little bit deeper and more pronounced around the chamfers, I can run the slightly deeper chamfer program like I did on this one. Now the next thing that needs to be done is we need to proof the outer rings for the beadlocks as well. Not sure if I'll do that this morning or not, but I might. You just got to make sure that those are all good to go, and those are a lot simpler than the faces, so hopefully that'll go a little quicker as well. This area should be the most accurate because I zeroed off my tool just to the left of that leftward hole there, and it looks pretty good. I'm happy with the very slight outer edge chamfer on it, and the inner edge chamfer is about the right size to allow for about a screw head's worth of space around the holes, which is nice. I think it'll look pretty good. Well, I'm done for now. I'm pretty happy with the progress I made this morning. It's starting to get a little warm out here, so I don't really want to keep working on this. And I don't feel like making a mess, getting all wet and sticky, you know, because cooling kind of tends to make a mess. Next up, we'll be actually machining these parts out of aluminum. I'm ready to start running my first program, and I'm going to start with the rings. And you're probably wondering, what is with this blue stuff? Well, it's a piece of aluminum that I got for cheap as scrap at my local metal supply. And I figure, well, I might as well try and make some blue rings. That would be really freaking cool. If I can't and it just decides to like chip off, like, oh well, I'll just scrape it off when I'm done. But I figure it's worth a shot. It seems like really durable stuff. I scraped off the paint on the back and that was very difficult. So hopefully it'll be really durable and it'll withstand the machining process. But if not, no big deal. I'll just like wire wheel it off or something like that. But with that, I am ready to get started. Let's go. those who are new to the channel, because we have been getting a lot of new subscribers recently, may be a little unfamiliar with what I just did here. Now, it looks like I just basically made a landmine of screws, but not quite. Essentially what I've done is I've held down both the rings and the waste pieces in the center of them. See, this is what it's going to be when it's done. So basically this part is going to be loose, and so will this middle section. So I need to make sure that both are held down adequately so they don't come flying out and, you know, break the mill or something else like that. So yeah, so far so good. Hopefully that should be enough screws to get it all held down and not come flying out, because I was having major issues with that at one point, not on this project, but another one. But yeah, let's keep going. Well shit, I think it works, guys. I was a little dubious about the whole blue thing at first, because the tool, you know, cuts upwards, like an upward spiral, so it was kind of pulling off some chips around the edges. But after the chamfer, it seems like it went pretty well. Let me pull them out real quick and I'll show you up close. Okay, so overall, the rings turned out pretty good. I'm relatively happy with them. However, there are a couple little things that are mildly annoying. This issue being one of them. The screws took off some of the paint when I tightened them down, and also I ended up scraping off some of the paint here on this one, because some of the screws got stuck really bad, like to the point that I had to kind of chisel them out with a screwdriver, which was quite annoying. The other issue is, this one's a good example. So as you can see, it's real thin over here and it's thicker on this side. It's because this side was slightly higher than that side. So all in all, I'm relatively happy with the way that they turned out. We'll kind of have to see where it goes from here, see how much worse they end up looking before the whole thing's actually done. Because if they end up looking really bad at that point, I'll probably just use a Scotch-Brite pad on a die grinder and just get them buffed off. So I was going to do the other set of rings today, but I remembered that I have a friend that wants to learn how to use this Milltronics machine, and I figured, well, the rings are a pretty simple program, and I already know it pretty well at this point, and it'd be a great one to learn on. So I'm going to save that for tomorrow. And today I'm going to do the faces. So I've got my material clamped up in the back there. I used some extra hold downs for the plastic base to the table so that the plastic would sit more flat, if you know what I mean. Like instead of like this, whoosh, squishes down flat a little bit better. That's what was causing the uneven paint on the rings that I just showed you. So hopefully that should take care of it for this, because the chamfers on this are a little more touchy, as I was explaining earlier. So yeah, should be good to go. Let's get to it. The wrong chamfer program on this one. I mean, thankfully I caught it before it went on to any of the others, but that is really annoying. I mean, the rest of them look pretty good, but God, yeah, that's just seriously freaking annoying. But to be honest, I'm not really expecting these to hold up. I'm expecting them to bend. I just don't think there's enough structural material there for them to actually hold up to tumbles and stuff that the MOA is going to take. So I'm thinking I'm probably going to end up remaking these faces at some point. So it's not the end of the world. And I'll use it for now because it's a set of 4 that I have to make at once. But still really annoying. Anyway, here's one of the faces. I honestly think that it looks pretty good. The design I think is really cool. I am noticing that there's a bit of a burr on the back edge of the outer edges here, and also in on these guys. I think that's just because my cutter is starting to dull a bit. I have cut out so many chassis and done so much milling with that one cutter, so I think I'm going to probably get a new one soon. That should help clean up those burrs a little bit. But they're not really noticeable and you're not really going to be touching that anyways. But everything else, the chamfers and stuff, they feel so nice and smooth on my fingers. I took and put the rings here on top of these other ones. And I gotta admit, they look really freaking cool. Really, really freaking cool. This one is the one that I messed up with the chamfers. But honestly, you can't really tell, which is nice, because there are going to be little standoffs underneath there, and I don't think you're really going to notice, so I will forgive myself on that one for now. Both sets of rings are now done. My friend had a great time with it, and he did a really good job, so that was pretty cool. We had a good time. I also bolted up my faces, and they bolt up absolutely perfectly. I still need to clean up the backs of these. There's still some burrs on the backs of the faces and also on the backs of these rings, so I'll take some time a little later, clean those up. The rings also fit absolutely phenomenally into the tire bead. Like, come on, you guys can't tell me that doesn't look absolutely incredible. Like, it's such a nice tight fit. Man, it just looks so good. Really, really happy with the way those turned out. But for now, what we need to do is figure out how wide our spacers and links are going to be to get the 2 rings sandwiched together. So my mock-up is done here. I kind of used the edge of the table as a reference for the wheels, front to rear. That one's turned inside out. You guys will see why later. But what I came up with is that I want my total wheel width, ring to ring, to be 1 3/4 inches wide. On the rear, because the rear axle is narrower than the front, I'm going to have a 3/8 inch inner spacer, and on the front inch I'm going to have a 3/4 inch inner spacer, and on the rear I'll have a 1 1/4 inch outer link and a 1 inch outer link. Those numbers will all make a whole lot more sense later once I actually get them cut and start assembling the wheels. You guys will see what I mean. I'm basically trying to make sure with the 2 different offsets, I'm trying to make sure that the width front to rear is going to be identical. Because the front axle is slightly wider than the rear, so I need a slightly shorter inner spacer on the rear. Again, it'll make sense later, but for now, I'm going to head outside, get started cutting all this stuff up. I mean, I'm going to need, no, 48 pieces altogether, 24 links and 24 spacers. That's a lot of work, so I'll see you guys later. 4.5 hours later, all my links and spacers are done. I know some of you guys said in my, I think, chassis video when I made all the spacers and links and stuff for the chassis that people actually make and sell standoffs and spacers like that for 3mm screws. And I know I could just go buy some, but if I can make it and save 75 bucks, great, because right here is probably about $5 worth of material and 4.5 hours worth of work. To me, that's worth it. To others, maybe not so much. Here are the wheels partially assembled. Hopefully this now makes sense why the different standoff lengths and everything were needed. It was to create different wheel offsets, like I was explaining before, but hopefully now it makes a little more sense to you guys. I also took some time to get a wheel mounted up on each offset of wheel. This one here is the front, and that there is the rear one. Now, as you can actually see the foam in there, and that's not going to be how it is in the end. And that is where these guys come in. So this inner ring here is going to sit on this bead of the tire. Now this is turned inside out, and just so I can demonstrate this, and also so that I can see just the diameter and clearance, make sure I get the right size ring going. But what I'm going to do is I'm going to cut out a couple more strips of 1/8 inch aluminum, and then I'm going to slip roll them into a ring. The seam here I'm going to TIG weld shut because I taught myself how to do aluminum recently, so I'll take care of that. That'll get welded up. I'm going to grind a bevel in there so it gets good penetration. I'm also just going to weld up those 2 holes there as well, because I do want these to be sealed in the end in the event that I decide that maybe I want to run no foam. Some of you might be wondering why I didn't just get a piece of pipe and cut it up to make these. Well, reason being is the inner diameter of this needs to be 3/16 of an inch or 77mm. Very strange dimensions that I didn't want to try and find online. I looked at my local metal supply shop and they didn't really have anything. The only thing they had was I think it was a 3¼ inch inner diameter pipe, which was really too big to properly fit that inner bead on the tire, which is unfortunate because this is a lot more work, but I get to use a slip roll for something which is not very common with the projects I do, so this is fun and it works out. But this goes inside the wheel, and then the tire bead rubber gets sandwiched there between the outer ring and this inner ring, and of course the back one goes on there like so. Now, right now, the inner ring is the same height as the wheel and all of its standoffs, which is not good because we need some space for the rubber, and I don't want the rubber to be the ending point of this all squishing together. So what I'm going to do is once I get them all made, I'm going to take them, clamp them in some V-blocks on the mill, and I will mill them down just a little bit. I'm going to start with them at 1 3/4 wide this way, and then I'll take them down maybe 1/16 or 1/8 of an inch, very, very little, but just enough so that I can get the screws clamped down all the way onto the back ring, but not cut through the rubber, basically. Wow, this is fucking disgusting. How am I this fucking bad? I don't understand. The fuck? I never claimed to be good at this shit. I can do it. Don't mean that it's pretty, but I can. To be fair though, I was trying to bridge a 1/4 inch gap. Not an easy thing to do with any style of welding, so oh well. I don't know how much more aluminum welding I'm going to do, but I suck at it. Okie dokie, so my outer rings are done. I belt sanded down the welds on the outside, used a carbide burr on the inside, and then my Dremel to smooth it out a little bit more, and then actually used a wire brush there, as you can see in the background, to give a nice consistent texture to the inside, because that's the portion that you're actually going to be seeing of this ring. Next up, I need to bolt the vise back on the mill behind me, grab my face mill, and we're going to dimension the thickness of the rings so that it will clamp on the tire bead just perfectly, not too much, not too little. It's going to be a bit of trial and error, you know, 10, 20 thousandths at a time, just trying to get it perfect. But once I get it perfect, I can just slap the other ones down and just machine them off, and that'll be nice and quick. I guess, yeah, that's it. Alrighty, there we go, nice. We're back inside, everything's cleaned up, and I'm ready to assemble. Well, there you go, guys. The wheels and tires are bolted up on this crazy rig, finally. The tires went on the wheels super well, which I was actually pretty surprised about because the rings were a little bit small. But overall, they look so good. The whole rig is awesome. I am a little worried about the suspension just being a little bit too weak for this big of a rig. I mean, it's as big as my freaking torso. Like, it's absolutely massive. For those that are wondering, the whole thing weighs 8.5 pounds, which I was originally guessing it was going to be about 10, but turned out to be 8.5, and honestly that's pretty good because that leaves a lot of room for weights, which are probably going to be necessary in the front. I'm already guessing that I'm also going to need to tweak the suspension a bit because it feels a little bit too soft for how heavy the axles are on this thing. So that's going to have to get adjusted in the future. The stock foams in these big Hyraxx tires are definitely going to be too stiff. I'll play with it for now like it is, but I'm most likely going to end up maybe cutting them smaller diameter or maybe doing the classic comp cut on them, but we will have to see. The other option is to get some dual stage foams. I don't know if Crawler Innovations makes foams for wheels and tires this big. If they do, let me know in the comments down below. This is not the last episode. There is still a little bit more that needs to be done on this thing. One item of which is I need to make a little antenna tube, because why not? I feel like it needs one. Just seems like, I don't know. For me, for the vibe that I'm built this rig for, it needs an antenna tube. So I need to make a little mount for that. And then I'm also in the process of designing my own custom body panels for it. I've been working hard on it. It's been taking me a while. They look great so far, so I need to figure out where to get those printed, and then we'll have to do that next time as well. Honestly, from here, I need to practice with it. So probably between now and next episode, I'm just going to practice driving it on my own, not really doing any heavy crawling, so I don't want to thrash the chassis before I do a really nice cinematic video with it. Plus, I'll be getting a new camera soon, so it'll be a great opportunity to test it out, do some awesome cinematics of this crazy rig. But yeah, thank you guys so much for bearing with me. Thank you for sticking along. Thank you for all the support. You guys have been killing it with all the views and likes and comments and stuff on this series, so thank you guys so much. I cannot do this series without your guys' help, so that's all I've got to say, guys. Thank you all so much for watching. If you did enjoy, please do leave a big fat thumbs up. Leave a comment down below. If this does happen to be the first video that you have seen by me, make sure you hit that subscribe button down below as well. If you want to support me and doing other builds just like this one, you know, help fund what I do, because this shit's not cheap. I'll tell you what. Become a member of the channel. That would help me out fantastically. Just a small monthly donation would go directly to me, and then I can make more crazy stuff like this. So that is all I've got to say, you guys. Thank you again so much for watching, and I will see y'all in the next one.